So like, I don't agree with never nesting. I'm a never nester. I write code that works. And I think that nesting is good. And I'll give you an example for why I think it's good. I can use folding in my editor to essentially create a function here that would tell me that I'm drawing the Diablo bar here. And then I have the draw hero list folding as well. And that way I can literally have local functions that allow me to easily tell what's being drawn and what's being done. Who did that? Who was this? G-God Life. Okay, you're getting banned. You tried to interrupt me. 5 minutes. And I'm gonna disable notifications. Banned for using channel features. Yeah. You can nest too much, but no nesting is all ridiculous. Yeah. So like, I like nesting because for me, the further I go to the right, the less space I have in typing, which is terrible. But the more I can use local scopes to, you know, section up code. But I know that, you know, sometimes it is a lot. But again, I also don't have, oftentimes I don't have the use case to create a function because it's only in one place. So why should I create a function if it's in one place and only in one place and never in other places? That's how I see it. But I would like to know why this guy says we should never nest code. I think it's an early return feature, essentially. But we'll see.
I have to admit, I'm a never nester. I know, shocking.
Cringe.
But there are more of us than you think.
Dozens. Cringe.
Even Lynn.
How many are there? 2.7 million, 113,000 likes. Ooh, but there's 2,000 dislikes. 2,000 people disagree. We are on the 2,000 list, guys.
Torvalds is one.
No, early returns are good. Yes. The inventor of the Linux kernel is a never nester.
I mean, I haven't asked him, but I'll show you what I mean in a little bit. You might be wondering, well, what is a never nester? A never nester never nests their code.
Of course we.
Okay.
Right?
Not never, but we do have a disgustometer which grows uncontrollably as the number of tabs go up.
No.
Nesting code is when you add more inner.
Let's see here. So we we iterate over a number array, and then we check if the number is a certain value, and then we return true. Sounds reasonable. I mean, there is a standard library function for this, but that sounds reasonable. How else would you implement that? This is fine, right?
Blocks to a function. We'll consider each open brace to be adding one more depth to the function. So this function is one deep because there's no inner blocks. And if we add an if statement, we've made it two deep. If we add a loop, we've now made this function three deep.
Let's see here. 1, 2, 3, 4, 5. I mean, I think that's fine, right? If, for, if. Oh, look at that. For, if, for, if. I think that's okay.
You serious?
Yeah. Sounds good. It's totally fine, yeah.
And this, my fellow programmers, is the maximum a never nester can handle. A never nester
Wait, 3? Is the maximum they can handle 3?
doesn't dare to go 4 deep.
What?
Now, the perverse among you might wonder what 4 deep even looks like. And while it brings me
I know what it is. And your mama too. Okay,
great pain to do, I understand that I must show you for science. Here is 4 deep.
Okay, bro. Weaklings, yeah, never nester equals noob. True, true, true. They're all newbies. Okay.
We've now taken a reasonably...
Guys, we write code that works, okay? Not that is beautiful. We need to code that works.
readable function and dramatically increased the amount of conditions your brain must simultaneously hold. But what can we do about it? Well, there's 2 methods you can use to denest.
Okay.
Extraction.
Yeah.
This is where you pull out part of the function into its own function.
Yeah, but then you still nest because you call the function in the function. That's still nesting. Because, like, it goes deeper. It's just a local scope in a function. No.
An inversion.
Yes.
Which is simply
Inversion?
flipping conditions and switching to an early return.
Early returns are nice. I really like inversion. It's a cool name as well, but yeah, early returns.
Let's look at extraction first.
Yeah.
We can extract the inner part of the loop into its own function.
I would create a function to check if a number is 2 or modulo by 2 is... Hey, really? Why? Filter number?
Now we can apply inversion.
But this is giving me... This code says the number is odd or even. Filter number, yeah. Hey?
When you put the happy path of code within deeper and deeper blocks, it creates a lot of nesting. Instead, we'll invert the condition and put the unhappy first.
That's what I would
First,
do
we'll
too.
flip our if-else by inverting the condition.
Yeah. And then we return here and we get rid of the else. We just let this code run down below.
Now, since we can return here, we know that the else block isn't actually needed.
Yeah.
So we can flatten our else into
I
the
like
main
that
level.
as well.
Now, if we hit our unhappy case condition here, we simply get out of the way.
Yeah.
And then the main part of the code can do its job. When you have a
But
lot...
it's still a function, man. And the function, so like, listen, you can do it this way, but filter number. Now, let's say you have a longer function. Okay? Let's say you have a longer function. And now you are in so far down that, and we can argue about functions not being longer than, 2 centimeters and whatever, we can argue about this or not. Let's say you have one, because it's a really difficult function. Okay? If you are so far down that you don't see the top and you have created multiple of these filter number functions, you don't know what they do. Now, what do? You are in line 50, which is still reasonable. I'll take you're wrong, you're banned. That was a bit too long, I'm sorry. Someone can unban him. 20 minutes a bit too long, but okay. You don't know what filter number does. It's a bad name. What does it filter? Yeah, so in this case, you know exactly why the number gets filtered, how it gets filtered. And so if you have these weird function names, now not only do you have to have a proper name for the function, you also most likely have to jump to the function to understand what it does. And so now you are no longer reading top to bottom. You are jumping back and forth all the time. You're jumping up and down and up and down. And I don't see this as a very good reason to break up the code, especially if you don't need filter number anywhere else. That's just my personal opinion, because for me it became so much easier to read my own code, even old code, if I know exactly what's going on. Now this is a cherry-picked example. Let's not spend too much time on this. Could be a reason to have a function here, but I wouldn't do it for this particular case.
The main part of the code can do its job. When you have a lot of conditions to check like this, we can apply
register user. Oh god, if parts.length is... So this is the early return here. If we don't have enough data, we early return, that's for sure. And then we check the user ID and we get the user name. And then we need to check if the user ID exists. And then we get the user by the... or actually, it's called register user. Okay. If the key exists, then we set the name. Otherwise, we create a new name. We have 2 early returns and then an if-else case statement in this case. So yeah, I would early return on the length, and then I would early return on the user ID. And I would even early return on the username. Like, what if the username is just empty? So there's 3 early returns here.
by inversion over and over again.
Yeah.
And we end up with a sort of validation gatekeeping section of the code, which sort of declares the requirements of the function.
I actually really like that, by the way, because it does help a lot to be able to read this on top. In my opinion, it's clean, because then you know all of the conditions that are supposed to be there.
And then we have the crux of the real functionality here.
Yeah, but the username needs
And
to
you'll
be
notice
checked
that
too.
the happy path moves down the function. And
Yeah.
all of the error paths, they're indented. When reading this code, I find I can mentally discard the condition and focus on the core code.
Yeah, I like
Versus
that
when
too.
it's nested, I find myself having to hold these ideas in my head.
I think this is bad too. You shouldn't do that, yes. Early returns is really good.
I'm curious if you experience the same thing. Let's look at a larger example. All right, look at this beauty.
While true, this is your running loop in a game, for example. Then we have a string path. And we have requested URLs. I guess that's a server or something. Downloads.add, new download state. Or I guess we are downloading something from the internet or something. And we have a connection established. Or we are not disabled yet. Then we do something. Chat's in the way. Oh, I see. Sorry about that. What was I talking about? Oh yeah, so this is another early return. And then, oh god, downloads, list iterator. I guess it checks the state here, and if the iterator has next. Wait, so he's checking this twice? Okay, so you can literally lose your connection at all the time. It downloads, and then if it's pending, then it creates a new downloader and starts it. Then moves to, okay, in progress. If it's in progress, then I guess it will try to process the result, and if the result is there on success, it moves to complete. I don't know. I like this code, man. This code's nice. What's the problem? It's a state machine in a way. It's a different states. You can do this in a switch case statement, of course. 50 lines in one function, already one problem. I mean, it's essentially downloading stuff from the internet. If your function is supposed to handle downloading stuff from the internet, and there needs to be different state changes, I don't see this as a big problem. Like, you want to make a function for each state? I don't know. I think this is fine. I would create a switch case statement here. Otherwise,
before we go refactoring it, let me walk you through what's happening.
Oh god.
The goal of this code is to
function.
download a bunch of files from the web. It talks with this download class that we can't alter. It's an async download.
Yeah.
So when we start the download, we have to call process over and over again.
Yeah.
And each time it gives you one of these results.
It gives us success, in progress, connection error, timeout. Okay, yeah.
If it returns in progress, we'll need to keep calling process more. On top of that, we want to download multiple files at once in the background. So we've created a thread that manages all of them.
Yeah.
The way new downloads enter the system is through this append download method, which puts the requested URLs onto a queue. The thread then wakes up and grabs the URLs from the queue, and then adds them to this list of current downloads.
Yeah.
Each download is given a state, which is either pending, in progress, or complete. So on each cycle of the main loop, the thread walks through each download and checks what it needs to do with it.
Yeah. And then it handles
If
the
it's
state.
pending, we start a new download.
It's actually really easy.
If it's complete, we simply remove it from the list.
Yeah.
If
Switch
it's in
case
progress,
statement.
we call that process method we mentioned earlier and figure out what's happening with the download. If it's completed successfully, we mark it as complete so it can get removed from the list. And in progress means we do nothing because it's still ongoing. But things get interesting if we hit an error. If the connection was okay, but we got an unhappy HTTP response,
Yeah.
we determine whether the error is retryable. If it is, we retry up to 3 times, setting the download back to pending.
Yeah.
Once it's failed plenty, we eject it from our download list and push it to a failure queue for someone else to deal with.
Okay.
For a connection error, we retry 3 times. Then we set this special connection disabled flag. And this causes us to basically give up on every download and clear the list. Okay, so there's a lot going on here.
Okay.
And it's all heavily nested in this function, which makes it hard to follow. So let's apply extraction and inversion to flatten.
We can extraction. I don't know if we can extract, but we can definitely do inversion. Mom, Dad, stop fighting. What is going on in chat? Guys, I know C++ is a hot topic, you know, but it's fine, guys. It's just a programming language, okay? Guys, it's all good.
The first 2 big candidates here are the 2 big branches of download processing, pending and in progress. So let's extract these out.
Why would we extract these out? They are clear and day to read here. There's no other piece of code in the program that needs to call this. piece of code. And it's super easy to see what's going on here. I don't see why we should do that.
Process pending.
Process pending. But this is bad because we don't know what stage it changes to after. Yeah, fine. I mean, I don't like it. To satisfy their OCD, I wouldn't do this. I think this code should not be extracted out like this because now we don't know what process pending does. And you can see right here that we scrolled down so far that we don't know what it does and we have to go in there. Function names are bad. I don't think you can have a perfect function name unless you describe everything the function does. So essentially what this function does is process. Wait a minute. This is actually just starting the download. And then it always moves to in progress. So calling it process download is not even right. Because it's not processing it, it's starting it. Okay, maybe process pending? No, this should be the correct function name from this, if you know exactly what this does without having to look at the function, would be start download from pending, essentially. Because that's what it's doing. And change to in progress.
And in progress to process in progress.
I see why he's naming it this way, but okay, I mean, process in progress, okay, fine. I mean, I wouldn't do it this way, but okay, fine. Let's say, yeah.
That's a bit better. But this
it doesn't change nesting though. It's not starting the download, it's prepping it. Yeah, I mean, it's then in the pendings, in the progress state, yes. But it's still, that's the start of the download. It's progressing something. If it's not started, it's pending. So I would call it start download, because that's what it does. It's progressing it then. Progressive iteration accumulator expressor class.
Progress function is still too deep for my liking. The worst offender.
What do we do here? I mean, we have a switch case statement, and we have the result. Result.getCode. If it's success, if it's in progress. Why though? I think that's fine. This is really good. It's perfectly readable. What? Sorry. Huh?
Is this HTTP error section. So let's move that out as well.
Handle HTTP error? Yeah, so you're assuming that you use this all the time in other pieces of code, but you probably won't because you're talking about downloads here. So this is not a good name for the function because it's supposed to handle the HTTP error of downloads.
Now, we'll keep extracting further in our run function.
Why do we need to extract
further? We have 4 major
further?
sections of our code. Where we process incoming requests from the queue, where we deal with our current downloads, where we clear out the in-progress downloads, and where we wait for the signal that there's new downloads to look at.
Yeah.
So, let's do it.
Why though? This looks awesome. It's like a book, guys. What you read here is a book from top to bottom. Now, with a couple of function names, but it's good. This is a long function. No, the function is now very small, but all of the function is in like what we did. Essentially, we did this now, guys. People are gonna hate this, by the way. Let's go. So essentially, we did this, right? We had this. Okay. This is what we had. And let's say there were certain parts. This is what the code was before, okay? That's before. And now what we did here, and we could create these sections, okay? This is one section, all of these different colors. You know, then maybe there were some sections like this as well. And I guess one last here. And these all had orders, right? So this was 1, this was 2, 3, and 4. And now we, essentially we created this, and this could go even further, right? So we have 1 here, then we have 3 here, we have 4 here, and then over here we have like the original function. If we like say this is white, we have this now, which is, I guess, 0. We could say that's 0. Then we have, I don't know, we have this block here and a little bit more on top and on bottom. So we essentially change the order. We're counting 1, 3, 4, 2 now. And this could go even more. That's always how I see it when I program myself. I see people doing this. That's like essentially I have this list in my head. 1, 2, 3, 4. And this is what happens after the refactoring in my head. And like for me, this is more difficult to follow because I now have to jump between places. Essentially, I have to maybe, you know, like I would be in this location in the code here, and then I would jump here. Took a look at this. Then I would jump back here, and then in here I jump back here, and then maybe I'm done, and then I'm here, and I jump back to 4. Only to jump back here. I don't like that too much. In a way, you're adding a go-to. So that's how I see it. Like, that's why I don't like this type of nesting too much. But early returns, again, are really good.
Lines the steps that are happening. You can see the high-level logic I described before. And if you were to dig into...
You can see the high-level logic, he's right. But you don't know what's actually happening. To figure out what's happening, you need to jump 2 places a lot.
Any of these functions, they're also concise.
You don't need to jump to the function if the name's good, but the more the function does, the longer the function name is if you want to know exactly what the function does.
At the beginning of this video, I mentioned that Linus Torvalds is a suspected never nester. And I say this because...
If they are all pure functions, it's a lot better. Yes, like if you have pure, like I should add this, right? If these are pure functions, and obviously these exist and you can make those, then it's a lot better. Because oftentimes, not all the time, but oftentimes you will also reuse pure functions. Because they are just so minuscule in what they do. Yes.
The Linux kernel style guidelines, they state, if you need more than 3 levels of indentation, you're screwed anyway, and should fix your program. The kernel dudes are always so dramatic. They visually enforce this by making the tab size 8 characters wide. This is what 8 characters look like with heavy nesting.
Guys, I have 2 tab spaces. The idea is you create some small piece of code that just works, so next time you need it, you don't spend your energy on recreating / fixing it. It's called abstraction. I agree with you. And I do that a lot myself as well. But I only do it if I need it in more than one place, or if the function name actually makes sense and I might need it. But for longer functions where the code needs to flow in a certain direction and I need to have specific things happening in specific order, I don't do that because I can't have this as a function anywhere else because it is too specific to the problem. Do 8 spaces for fun, just for a second. Do 8 spaces for fun, just for a second for my game. Bro, you know what you're asking here? Nothing changed. It doesn't change the code, bro. Let's change that back to 2, bruh. No. We're not gonna do that. Git push first? Hell nah, bro. I don't have an auto formatter. That's why. It would have probably done this with auto formatting. No. Cakez. Needing that code in more than one place is a requirement, but by your logic, you need everything in one update loop, so that's still a place no abstraction is required. Potentially, you could do it like this. If you, yes. Like, if you go to the extreme, you would essentially, let's say you have one update loop and you only have one file, your main CPP. And in the update loop, you create a locally scoped function, let's say a Lambda function, which is, I don't know, get entity. And then obviously this function would be called further down, right? This locally scoped function would be called further down because you would need to have this as a function because you would call this multiple times. You know, you would call it here, 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 here. You could do that, yes, of course. Now there are some, you need some functions. I'm not saying don't get any functions or don't use any functions. I'm saying if there is a function or a place where code needs to flow in one direction, just chunking this code into pieces because it is too much indentation, I don't see the reason for that. So yeah, anyways, I knew this video would spark a lot of discussion and I was right. Chat is having a lot of fun right now by proving each other wrong and, you know, telling each other how terrible of coders they are. And no, my way of coding is better than yours and you need to learn how to code. And I have 10 years of experience and you only have 2. So yeah, it worked. Very nice.
Admit, I'm not that committed to the cause, but I am into limiting indentation.
Me too.
I believe that
as weird as that sounds, I am into early returns a lot. I think that's the best thing to do.
Constraining how much you nest forces you to write better code. If you notice, instead of one large function that handles many things, we now have small, concise functions that have one responsibility.
Yeah, but we lost the overview, kinda. Like, yes, this, but we lost the detailed overview. That's how I see it. Anyways, that's enough.
What do you think?
Discussion. What do you think? Good ideas. I wouldn't create all of these functions though. I would he had a point.
Almost a decade.
Stop it. He had a point where the program looked really good. That was before the handle HTTP error, I think. This point here was nice. I liked this point where he still had the HTTP error in there.
But this in progress function is still too deep for my liking.
This one here, this one is good. Like I wouldn't, yeah. I think it's got a point, but he's going overboard sometimes. I think what happens here is if you follow rules a little too much, simply because they are rules and you don't look at the situation that you are in or the use case that you have, and you just do it for the rules and not for that use case, I think then that is when you start making mistakes. And you should, in my opinion, always take a look at the use case and then decide on whether you should want to create a function or not. Because essentially there's only one update game loop in the game when you're making a game. Should you now not have an update game function? I'm not saying that, because yes, you should. It's just a ginormous function that has many other sub-functions that sometimes get reused and sometimes are not. And obviously it is up to you to decide when to create a function and when not to. When to extract code and when not to. And I think there is no hard rule for this. I think it's just situational. That's how I see it. It is depending on what type of use case you have. So if you guys would like to support the non-nesters, there we go, here's the video. And if you guys would like to support Code Aesthetic, you can subscribe. And he looks like he has a Patreon too. Actually quite a few members. Damn. These are all non-nesters, guys. 1,300 non-nesters. Almost 1.4k.